section 7.4. And before we begin the section itself, let's review some things like a basic logarithm. Let's say log base 2 of 8. What's the answer there?
3.
The answer is 3, right? Now, if I asked you why is the answer 3, you would say what?
2 to the 3rd equals 8.
Yeah, because 2 to the 3rd equals 8, right? And this is technically rewriting it from logarithmic form to exponential form, right? Now, what if I asked you, instead of log base 2 of 8, what if I asked you log base 2 of 0?
1.
So you're telling me that 2 to the 1 power equals 0? No. Okay, so you're saying 2, somebody said negative 1? You're saying 2 to the negative 1 equals 0? No. You can't do it, right? Can't do it. So let's understand that. You cannot do log base anything of 0 because there's no way that with an exponent you're going to be able to convert it to nothing, right? Even if you had like a fraction, you would not be able to convert that to 0. We wouldn't be able to convert it to nothing. So this is just, you can't do it, right? Can't do it. And that's an important thing in today's lesson when we're solving logarithms. What do I mean by that? Let me go to, you guys remember solving square root equations? Like if I had an x plus 2 equals something like 4 over here. If we had something like this, yeah, you would square both sides to get rid of the square root. But you would also have to make sure that the inside value did not end up negative. You guys remember that? Okay. And so if you got an answer and it gave you a negative in here, then that would be an extraneous solution. Or even better, back when we did solving square root or cube root inequalities, we had to solve it the way we normally would. And then we would also have to go back in here and say that that x plus 2 has to be greater than or equal to 0, because if it's negative, then it's imaginary, right? Remember that? Okay, so we're going to kind of have to do this on logarithms. Since we just said that you can't do the log of any type of log of 0. You can't do that. So we have to, when we solve inequalities, we have to go back to the inside of the logs and make sure that those values are greater than 0. Because if it's equal to 0, then you're not going to be able to do that logarithm. It'll make more sense once we actually get to it on the worksheet. Let's do that right now. So here's our worksheet. I'm going to explain, I'll go for the odd ones, I guess, on this video. How the heck do I do number 1? Obviously, I need to get x by itself. Is there 1x? Yes, it's on the left side. That's great. The question is, what is this answer right here? Log base 6 of 216. In other words, 6 to what power gives me 216? 3. 6 times 6 is 36 times 6. It does end up being 216. You could check that on a calculator. So you have 3x equals 3. So then what? Divide by 3, divide by 3. X equals 1. Ta-da! Easy peasy. Moving on to number 3 over here. We have log base 4 of 4x minus 20 equals 5. I want to solve this thing, which means I want x by itself on one side. X is inside, it's inside this logarithm base 4. So I do not want the logarithm base 4. So Frida, what am I going to do to get rid of that log base 4? Well, we have to get rid of the log. To get that x, to get this x out of this log base 4, we need to get rid of the log. So how do we get rid of a log? With the inverse of a log, which is a
Power.
Exponent, power, right? Okay, so in order to get rid of log base 4, you're going to take the entire side of the equation and raise it to be the power of base 4. And what you do to one side, you do to the other side, raise that to be the power of base 4. And you technically have your equal sign between those 4's. So your equation really is 4 to the log base 4 of 4x minus 20 equals 4 to the 5th. Yay? Now, of course, we do that so that the base 4 and the power of log base 4 eliminate, and this guy comes down. So your equation is actually 4x minus 20 equals 4 to the 5th. And what is 4 to the 5th? I don't even know. Anybody have a calculator? So that would be 4x minus 20 equals 1,024. And if I add 20 to both sides, it would be 1,044. So we'd have 4x equals 1,044. And we divide by 4. What do we get, guys? Those of you that have calculators? X equals what? 261. Let's double check. Check the backside and make sure that this is correct. Yeah? Also, you need to check and make sure that this 261, when you plug it into the log base 4, you don't end up with 0 or any negative numbers, because we know that logs can't have zeros or negatives, right? So yeah, of course, if you type in 261, 4 times 261, that will be huge, and it doesn't matter if you subtract 20, it'll be a positive number, so we know that it's good. Anyway, let's move on to number 5 here. What do I do to get rid of the log base 81? Raise it to be the power of base 81. Raise it to be the power of base 81. Your equal sign's right here, no longer up here. So what you really have is 81 to the log base 81 of x plus 20 equals 81 to the log base 81 of 6x. We know that the 81 to the log base 81 eliminates. 81 to the log base 81 eliminates. What do we have left? X plus 20 equals 6x. And of course, we're going to solve this thing by subtracting x. We will have 20 equals 5x, which means x equals 4. Beautiful. Now, just double check, quick second, plug in 4 right there. Will you get a negative in here or 0? No. If you plug in a 4 right here, will you get a 0 or negative? No. So you're good, right? Moving on to number 7. So again, the idea is I'm doing the odd ones. Hopefully you do the even ones for homework. And if you don't understand the even ones or you're struggling at home, you should have a video uploaded later on tonight. Let's get rid of the log base 4 right, by raising both sides to be the power of base 4. So you really have 4 to that stuff equals 4 to that stuff. And we know that 4 to the log base 4 eliminates. 4 to the log base 4 eliminates. We end up with x minus 1 equals 12. And when we solve this thing, we're going to get x equals 13. Okay, now the question is, if I plug in a 13 here, will I end up with 0 or a negative? Nope. If I plug in, well, that's the only place to plug in 13. So that's it. We're good. That must be correct. You know, the crazy thing, guys, is that the Casio actually has a button that does logs other than common logs. It's actually pretty cool. Let me show you. So we talked about common logs right here, and we also talked about natural logs, log base E. But on the Casios, not on the Texas Instrument, we actually have this lucky, amazing button right here, log base whatever of whatever. So you could actually type in log base 4 of 12. Now, why would I type in log base 4 of 12? Because my answer is 13. So if I type in a 13 right here, 13 take away 1 is 12. So if I do log base 4 of 12 on the calculator and I get this answer, 1.79, blah, 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 and then I try the log base 4 of 12 and get that same answer, then I know it's correct. And actually, we know it's correct because log base 4 of 12 is equal to log base 4 of 12. Anyways, the calculator actually does these different bases. Back when I was in high school, they wouldn't have this button, and we'd have to memorize this formula called change of base formula. I'm still going to show it to you and still going to introduce that, ask you to memorize it also next week, not this week, but calculator actually does that for you. Moving on, number 9. What do I do here?
You make the exponent a x.
Make it an exponent of x. That's exactly right. If you want to get rid of this log and its base x, you're going to raise the whole thing to be the power of that same base that's on your logarithm. So it'll eliminate. And what you do to one side, you must do to the other side. So you're going to take that 2 and raise it to be the power of base x, which means you got an x squared on the right side. The equal sign's now right here. So you have x to the log base x of 5x equals x to the second. Now we know that x to the log base x eliminates. The 5x comes down as a regular 5x instead of an exponent, and we have the equal sign, and on the right side we have an x squared. Anybody remember from semester 1 how to solve this guy? If we had x squared equal the number, yeah, I would square root and square root, but we actually have two x's, right? Okay, how about this? This is an equation, and it's a power of 2, which makes it a quadratic. And we used to solve quadratic equations a lot during semester 1. You guys remember that? Let's subtract 5x to move it over. Subtract 5x. Now, you can't really subtract, but we're going to rewrite it. We will have, let me write it in red, x squared minus 5x. I want to put the equal 0 on this side. So we have a quadratic equation that we used to solve in semester 1. What would we have to do to factor? I said factor. To solve. You factor, right? So what could we factor out of the left side of the equation? X. So let's pull out an x. And what would we have left? An x minus 5 on the inside. You still have it equal to 0. And then we use the zero product property. Something times something equals 0. So that first something could be 0, or the second something could be 0. So we have one answer here, and the other answer will be 5. X equals 5. So we have two answers here. The question is, will both of them work? No. Which one will not work? The 0 will not work, because if I plug in 0, I have 5 times 0, which is 0, and we know that log base anything, you can't end up with a 0 in here because it won't work, right? There's no real answer to that. So 0 doesn't work, but the 5 does. And on the back on the solutions, it should just have the answer 5, no 0. Moving on to number 11, we're finally down to inequalities. The second half of this homework is inequalities. And it's the same thing as equations, it's just one more step. Just like similar to square roots, when we would solve inequalities on square root inequalities, we would have to solve it and then go back to the inside of the square root and make sure that we ended up with something that was greater than or equal to 0. Because if you have negatives inside square roots, you end up with imaginary values. So right here, we're going to solve it the way we normally do, but in addition to that answer, Hannah, we're going to go back to the logarithm, to the inside of the logarithm, and say that that value has to be greater than 0. You can't even say or equal to, because if it's 0, it doesn't work, right? So this guy has to be greater than 0, and this guy has to be greater than 0. So you're kind of doing like 3 simple problems. Which one should we do first? You want to do the easy one? This one right here has to be greater than 0, so let's just jot that down. X has to be greater than 0. That's one possible answer. And then we look over here. This guy has to be greater than 0. And when we solve that, minus 4, we end up with negative x is greater than negative 4, which means that our answer will be x is less than positive 4. That's another possible answer right there. And the other answer we get from actually solving this thing, all right? How do we solve it? We raise both sides to become powers of base 6. That way the 6 to the log base 6 eliminates. The 6 to the log base 6 eliminates. What do we have left? We have the x, we have the greater than symbol, and we have 4 minus x. And that's our inequality that we need to solve, and this is where we get our third potential answer. So let's get the x's on one side by adding x. Adding x, we will have 2 x's are greater than the number 4. Divide by 2 on both sides, x is greater than 2. That's our third possible answer. So how do we find out which answers actually work? We could go, again, kind of like in the past, go to a number line and see where the overlap is, right? So if we think about, let's actually go to a number, let's do a sketch of a number line right here. That is, hold on a second. Still crooked, whatever. We're gonna call that a number line. This guy is 0, 0, 4, and 2. All right, let me put 0, 2, 4, okay? So this guy right here, it says x is greater than 0. So here's 0, greater than is to the right. This guy right here says x is less than 4. And let me do this one in red. X is less than 4. Less than's to the left. Okay. And then over here we have x is greater than 2. So greater than is to the right. So where is the triple overlap piece? 2 and 4. So if we check our answer in the back, we should see that the answer is 2 and 4, x in the middle with the less than symbols. So we don't even mention that x is greater than 0. That's not part of our answer. It's where the triple overlap piece is. In other words, what area has all 3 lines? That's why I did them in different colors. Well, from 4 to 2 has the red, from 2 to 4 has the green, and from 2 to 4 it also has the black. You see, this is the area where there's 3 colors from here to here. So it's an area that's together between 2 and 4. So you put the 2 on the left, the 4 on the right, and put the x in the middle with the less than symbols. That's as hard as it gets. I mean, when it comes to thinking about the answers. What do we do here?
Get rid of the log.
Yeah. How about we do the easy one first, right? This has to be what? It has to be greater than 0. You can't say or equal to, just greater than 0. So, and this is only on inequalities, right? Where you have an area of answers. So on the inequality, this guy has to be greater than 0. So let's just write that down. X minus 5 has to be greater than 0. So your answer, or your possible answer, is x is greater than 5. That's one possible answer. We're going to have to test it on a number line. And then we go back and solve this whole thing like if it were an equation. Put it base 2, put it base 2. The log base 2 as a power of base 2 will eliminate. The 2 to the log base 2 will eliminate. What do we have? We have an x minus 5 is greater than 3. So I need to get rid of that minus 5 by adding 5, and you will have x is greater than 8. So let's think about those two answers. Think about them on a number line. We have the 5 right here, and we have the 8 over here. Now let's look at the 5. It says x is greater than 5. Greater than is to the right. X is greater than 8. Greater than is to the right as well. So what's my overlap piece? 8 or greater. Does that make sense? Okay, because the black one goes this way forever. The red one also goes this way forever, but it doesn't start overlapping till right here. So that's just x is greater than 8. X is greater than 8. So this x is greater than 5, you don't include that in your answer because all you want to do is represent the overlap piece. Number 15, what do I do? Let's do the easy one first. 3x minus 3 has to be what?
Less than.
Has to be greater than 0, right? 3x minus 3 has to be greater than 0. Now, think about it, guys. If you try on your calculator to do common log negative 2 or common log negative 10, it's going to say error. It doesn't work. Even if you say log of 0, it's not going to work. So we know that it has to be greater than 0. That's the only way you're going to be able to actually do the log is if your x value, if you're taking the log of something that's greater than 0. So we need to say that this guy has to be greater than 0. So this is how we get this simple inequality. Let's solve it. It's going to be 3x is greater than 3, which means x is greater than 1. That's one possible answer. It might be included in our answer, maybe not. It depends on the overlap. And let's solve the whole thing. We're going to raise the whole side to be power of base what? 9. Over here, same thing. Raise this whole thing to be power of base 9. So 9 to the log base 9 eliminates. The 3x minus 3 comes down. The inequality comes down. And we also have 9 to the 1.5. Now this is where you got to dig back into the knowledge that you already have on exponents. And when they're not complete exponents, you have 1.5. That's really a 1.5. So on the side, you might want to do this. 9 to the 1.5 power. You could split the base and make it 9 to the 1 times 9 to the half. You guys remember that? What is 9 to the 1? That's just 9. What's 9 to the half? That's really the square root of 9, which is 3. So you really have 9 times 3, which is 27. Don't freak out. This right here the 9 to the 1.5, you could do that on the calculator, and the calculator will give you 27, right? Anyway, our equation reads 3x minus 3 is less than 27. And let's solve that guy. Add 3 here, add 3 there. 3x is less than 30, which means x is less than 10. That's another possible answer. Let's think about our number line. So we have 1 and we have 10. And the 1 says x is greater than 1, greater than's to the right. This one says x is less than 10, less than's to the left. So the overlap is between those two values of 1 and 0. So we're going to write this as a compound inequality because the areas are between those two values. So the answer right here, I'm sorry, there's not enough space to actually do all this work, but the answer will be your smaller number. Wait, did I do this right? I didn't do this right. Oh no, it is right, it is right. I put 0 instead of 10, that's why I'm tripping out. Yeah, 1 and 10, right? 1 and 10. So your area is between the 1 and the 10, x is in the middle with less than symbols. So that should be your answer on number 15. 17, going for the easy ones. Let's make sure that this guy is greater than 0. So we're going to say x minus 1 is greater than 0, which means that our possible answer is x is greater than 1. Now let's go to the other one over here, the 2x. We need to make sure that that 2x is greater than 0. So if we solve this guy, divide by 2, x must be greater than 0. That's another possible answer. And last but not least, let's actually solve this thing like if it were an equation. Raise both sides to become the power of base 9. That way the 9 to the log base 9 eliminate, and that eliminates. The x minus 1 comes down, the inequality comes down, and the 2x comes down. So now we have a regular inequality to solve right there. We have x's on both sides. I'm going to move this 2x over. We're going to end up with negative 1x minus 1 is greater than 0, which means that we'll have a negative 1x is greater than positive 1, which means that when we divide both sides by negative 1, we will get x is less than negative 1. Because when I divide by a negative, you have to flip that inequality symbol and it becomes less than. So we have these 3 possible answers. We need to go to a number line to see where the triple overlap piece is at. So let me go right above right here, do a number line. We have the value of negative 1, 0, and 1. So when we go to negative 1, x is less than negative 1, that's to the left. When we go to x is greater than 0 is to the right. And when we go to x is greater than 1, greater than 1 is to the right. Interesting, there is no triple overlap piece. What's the answer in the back? That makes sense. If there is no triple overlap piece, then there is no solution. 19, man, this is getting messy. There's a lot of stuff to do here. So on the inside, we want that to be greater than 0. So you have x minus 3 over 4 plus 5. We need it to be greater than 0. So you really have x minus 3 over 4 is greater than negative 5. If you multiply both sides by 4, you're going to end up with x minus 3 is greater than negative 20, which means final answer x is greater than negative 17. Now that doesn't automatically eliminate this answer possibility until you actually plug it in and make sure that if this whole thing is negative, then yeah, you could eliminate that answer possibility. Or you could just go with the number line to get your triple overlap piece. So let's do this other one. This other one is x plus 2. That has to be greater than 0. So if I do that right here on the side, x plus 2 has to be greater than 0. X has to be greater than negative 2 when I solve that guy. But let's go to the whole equation and let's solve it by raising it to be the power of base 3. So this could eliminate. Raising it to be the power of base 3, so that could eliminate. We end up with x minus 3 over 4 plus 5 is greater than x plus 2. So we have a fraction. Let's multiply everything by 4 to get rid of that fraction. We'll end up with x minus 3 plus 5 times 4 is 20 is greater than 4x plus 8. Let me show my work here, I'm sorry. Times 4 to get rid of that, times 4, times 4, times 4. That's how we get that inequality. And let's continue to solve this inequality. Combine the negative 3 with the plus 20. We end up with x plus 17 is greater than 4x plus 8. Let's move this x over there. We're going to end up with 17 is greater than 3x plus 8. We're going to subtract 8. Subtract 8. We will end up with 9 is greater than 3x, which means that x is less than 3. Yay or nay? Okay, so when we go for the testing of the areas or graphing on a number line, x is greater than negative 17. Here's negative 17 greater than that way. X is less than 3. Here's 3 less than that way. And x is greater than negative 2. Negative 2 is right here, greater than that way. So where's the triple overlap piece? Between what two numbers? Negative 2 and positive 3. So the answer in the back should have the compound inequality, negative 2, positive 3, x in the middle with the less than symbols. That should be the answer on the back. Last one, 21. Let's do the easy ones first, which is setting up the 7 minus x being greater than 0, which means that negative x is greater than negative 7, which means x is less than 7. It's one possible answer. The other one, x plus 19, has to be greater than 0, which means x has to be greater than negative 19. That's another possible answer. And the other answer is going back and treating it like an equation, raise both sides to be the power of base 3 so that 3 to the log base 3 eliminate, 3 to the log base 3 eliminate. We end up with 7 minus x is less than or equal to x plus 19. Let's solve this thing by moving the x's to the left side. We're going to end up with 7 minus 2x is less than or equal to 19. We get rid of the 7 by subtracting 7, subtracting 7. We'll end up with negative 2x is less than or equal to 12. So final step is to divide by negative 2, divide by negative 2, which means that you're going to have a sign change. X is greater than or equal to negative 6. So let's plug in, or let's graph these on a number line to see where the triple overlap piece is at. We have negative 19. We're going to do that in blue. It says x is greater than negative 19, greater than that way. We also have x is less than 7. 7's over here in the positives, less than this way. And we also have x is greater than or equal to negative 6. Here's negative 6. Greater than or equal to is that way. So where's the triple overlap piece between which two numbers? Negative 6 and 7. Now keep in mind that at the negative 6, it's greater than or equal to. So when we make our compound inequality, you're going to put the negative 6 on this side. You're going to put the positive 7 on that side. You're going to put the x right here, but this one's going to be a less than or equal to, and also this one is just a less than. Because this one was solid, because it was a solid line underneath it. That's why we kept that solid line right there. And this one didn't have a solid line, so we don't. It's open dot. So there's your answer for that one. I've done all the odd ones. Man, that's taken a long time. Go back and do the even ones, and you're good. This will be on the next test that we have. Instead of having a quiz tomorrow, we're going to have a test next week. Probably on Tuesday. Probably on Tuesday.